High-resolution wall-sized displays can accommodate a large amount of visual information. Viewers are often mobile. They can move away to get an overview or up close to see details. And so they require mobile input. However, visual exploration of complex data often requires access to many interactive controllers. We introduced SketchSliders, a mobile sketching interface for visual exploration, where users can directly sketch only the controllers they need. Users can manipulate their custom-made controllers to filter and transform their data on the wall display. SketchSliders can have arbitrary shapes. They can be circular, they can be grafted with branches, or they can express transformation functions over a data dimension. Such transformations can change the view of the plots on the wall. SketchSliders combine free-writing, sketching of controllers, and pen-based gestures. The following is the set of most basic interactions. Sketch a new slider and associate it to a data dimension. Cross and dwell to activate a contextual menu, for example, to change dimension. Scribble to erase, for example, a range filter. Cross twice with a pigtail to create a new filter. Change the range of the filter or move it along the slider's path. Create a delta filter with a simple pigtail. Cross with a circular gesture to create a slider cursor, and then move it to change its position. Users can also hold and drag an extremum to change its value. Visualizations are synchronized with the SketchSliders. Filter queries are communicated to a server, which propagates them to the wall cluster for rendering. SketchSliders are augmented with visualizations of density distributions. In blue, we show the data distribution of active filters. Distributions give quick overviews of the data, so users can focus on the mobile interface, reducing divided attention. They also help the user to discover dependencies between dimensions while they interact with different sliders. Distributions can be turned on and off. We have explored a range of SketchSlider designs to take advantage of their free form. Distinctive corners are handled as natural bookmarks. Users can tune their values and further annotate them. For periodic variables, such as month or weekday, we support circular sliders, which are sliders with no ends. SketchSliders can be grafted with branches. Branches allow for better detail and finer granularity and control. They act as proxies of the original slider, and each branch has copies of the filters. Branches can be nested infinitely, producing arbitrary polytree structures. Transformation sliders can help focus on a location of the data without losing context. They have a higher granularity closer to their high peaks. Transformation sliders also deform the visualizations on the wall display. This focuses the wall visualizations on the data ranges that correspond with the slider peaks. Selection of data points can be made either with slider cursors or wall cursors. Through a menu, users can activate an area cursor on the wall, which is controlled with the mobile touchscreen. The wall cursor can be resized with the fingers and glided on the wall. We conducted a user study with 6 visualization experts. Our participants were enthusiastic about sketching their own controllers when they needed them, and found that the combination of sketching controllers and decoupled wall visualizations worked very well. SketchSliders were flexible enough to support a range of different working styles and exploration strategies. We presented SketchSliders, range sliders that users can freely sketch on a mobile device to customize their data exploration on a wall display.